Great. So prior to our quiz, we're going to go through a couple of examples from 5.1. I know that we went away from 5.1, but now we're jumping back to it. Now that we've sort of mastered some ideas with 5.2, we're going to try and go back to 5.1 and learn some new ideas from there. So we're going to look at example 6a here, and then we're just going to go to example 7. But example 6a from 5.1 says, find all the x values in the interval from 0 to 2 pi. Solve 2 times cosine of x times sine of x minus cosine of x is equal to 0. So what we're looking for right now are the angle values that we could plug into this equation that will cause 0. Okay, we're looking for the angle values that we can plug in that will cause 0. So, okay, what our goal here is to factor and set our factors equal to 0 and then solve for x. And here we have a couple terms on the left here. And we want to be able to factor out something. And you guys see something we could factor out? We factor out a cosine from both of these terms. So if we factor out the cosine, we have cosine of x times 2 times sine x, and then minus a 1. We're taking the cosine out of there, so we're left with a 1. And now this is equal to 0. So now we've rewritten this equation into a problem that has now factors on one side. And so in order to solve for x, we can set the factors equal to 0. So let's go ahead and do that. We're going to set cosine of x equal to 0. And then we're also going to set 2 times the sine of x minus 1 equal to 0. So cosine of x equals 0. That's we just need to figure out the angle values that will give us 0 from 0 to 2 pi. For this one here, 2 times sine x minus 1 equals 0, we actually need to solve for the sine of x. So we're going to add 1 to both sides, and then we are going to have to divide both sides by 2. So if I divide both sides by 2, I end up with the sine of x is equal to 1/2. So I'm going to go ahead and erase this work here and pull this guy up here, this guy over here. And right now we're trying to figure out the angles that will give these ratios here. And so let's focus on one at a time. First one we're going to look at is the cosine of 0. And first thing I think of with this one here is, what's my definition for cosine? Cosine's definition is x over r. And we can relate that back to 0 here with the x is 0, and then the r value would be a 1 there. So where do we have x 0, r 1? We have to draw our circle, right? And we have a circle here. Where is x equal to 0? X is equal to 0 at this spot here and at this spot here. This is at x is 0, y is 1. And this here is at x is 0, y is negative 1. And at this point here, this is at pi over 2. That's 90, right? 180 divided by 2 is 90. So we have one spot that's going to satisfy that equation at pi over 2. The other spot is down here, and that's 3 pi over 2. Count them out. 1 pi over 2, 2 pi over 2, 3 pi over 2 is right here. So we have another solution here at 3 pi over 2. And that covers it for going from 0 to 2 pi. Good? All right, so now we have to think about this other ratio here with sine. And so I think about my definition for sine. Sine's definition is y over r. And I know that y is equal to 1 and r is equal to 2. I'm going to draw in the first quadrant here a y value here that's 1 and an r value of 2. We know we're in the first quadrant there because y is positive, right? And so what kind of a triangle is that? 30, 60, 90 triangle. 30, 60, 90 triangle. Remember that the side opposite of 30 degrees is 1/2 of the hypotenuse. So I knew that the 30 degrees is opposite of the 1 there. So that means that one of the angles that's going to give the 1/2 here for sine is 30. In terms of radian measurement, that's pi over 6. 180 divided by 6 is equal to 30. So where's the other one? It's going to be in the second quadrant over here. So I'm going to draw another triangle over here. And I have a 2 here and a 1 here. And what kind of a triangle is that? It's again 30, 60, 90. Except this time around we have to think about the angle measure that brings us to that point. And that is going to be at 150. We're 30 degrees away from 180. Excuse me. Got that on tape. All right. So, all right. Okay, so we want to figure out how to convert that into radian measurement. Because in the directions here, they're giving us radian measurement. So we could multiply 150 by pi over 180 and convert. Oh man, went away. All right. So what I like doing is I like thinking about the 150 and thinking how many 30s will fit in that 150. 5 30s will fit in that 150, right? And 30 degrees is pi over 6. So this is like saying 5 pi over 6. So these are the solutions for this equation. All right, so for example 7, we're going to find all the solutions to the trigonometric equation 2 times sine squared x plus sine x equals 1. So now the one thing that's different is we're not finding the solutions from 0 to 2 pi. We're finding all the solutions. So we're going to have to generalize some things. And also this one's a little bit different of a type of factoring problem here. If I were to subtract 1 to both sides of this equation, we would end up with a minus 1 here and a 0 on the other side. Does that remind you guys of anything? Does that sort of strike a nerve with any of you guys? Well, trig, yeah, but what type of factoring would this possibly represent to you? Quadratic. You know, if I were to say that that sine x is a y value and rewrite this, this would be undeniably quadratic, right? So don't let it scare you too much. We're just factoring a quadratic. And so we say what times what is equal to 2 times sine squared. What times what is 2 sine squared? Think about this over here. What times what would be 2y squared? That would be a 2y times y. So it's not much different over here. We say 2 sine times sine. 2 sine times sine is equal to 2 sine squared. Now what times what is equal to a 1? That's easy. 1 times 1. From here, I have to figure out what signs to put. And I want to think about the outer 2 multiplied and the inner 2 multiplied, and then the addition or subtraction of those to give me a sine x. So I know that a 2 sine x and a sine x are going to combine to give me a plus sine x. And I got to figure out what signs to give. I need a plus 2 and a minus sign there. And in order to get the plus 2, I need the 1 here to be plus. In order to get the minus sign, I need this 1 here to be minus. So let's go ahead and take our factors and set them equal to 0. We take those factors, set them equal to 0, and then we're going to solve for the angle value. So on one of these, if hopefully it's okay if I skip a step here. On the left factor, if we set that equal to 0, we're going to end up with sine x equals 1/2. On the right factor there, if we set that equal to 0, we're going to end up with sine x equals -1. Now what I want to do is I want to figure out the angle values that are going to cause these ratios here. So let's deal with one of them. Let's deal with the bottom one first. All right, let's deal with the sine x equals -1. So I got to think about my definition, right? I got y over r. So that tells me my y value is a -1, my r value's got to be a +1. Where do I have a -1 for y and a +1 for r? Down here. At this point here, at 3 pi over 2, right? At 3 pi over 2, that's where we have a ratio of -1 for sine. Okay? The problem is it says to find all of the solutions. All of the solutions. So just one solution, one x value, 1x would be 3 pi over 2, right? However, another x would be when we add 2 pi. If I add 2 pi, it takes me full circle to this point again, right? So if I take my 3 pi over 2 and add 2 pi onto it, that would give me another solution, right? I could continually add 2 pi forever, right? I could say, all right, we're going to add 2 pi. Again, I'm going to add 2 pi twice. So 2 pi times 2. I'm going to add 2 pi again. 2 pi times 3. You know, we could go in the opposite direction as well. We could not just go counterclockwise. We could go, we could not just go counterclockwise. We could go clockwise, excuse me. So we could go and say, all right, well, we're going to start subtracting 2 pi, right? We could say 2 pi times -1 there, go in the opposite direction that we've been going. You guys all with me so far? Okay, so what we've done here is essentially established a pattern. And this pattern here, we have 3 pi over 2 plus 2 pi times a number that is varying, right? This number is varying each time. So we're going to replace that varying number with a variable. And so the generalized solution here would say 3 pi over 2 plus 2 pi times some variable. I'm going to call that variable n, where n, we have to define what n is, where n is an what? Integer, exactly, where n is an integer. Alrighty? So that represents all the solutions for that particular one. So where is the sine of x equal to 1/2? We did that in the previous problem, right? If I jump back here, yep, that was it. Pi over 6 and 5 pi over 6. So let's just go ahead and write that here. We have a pi over 6 plus 2 pi n, where n is an integer, right? And then we also have a 5 pi over 6 plus 2 pi n, where n is an integer. So it is important to write what n is equal to in addition to the solution, okay? So where n is an integer really is a part of the solution. You have to define what that variable is. Y'all have any questions? We feeling pretty fantastic about this one? You guys want to give a shout out to the video?
Bye.
Yeah. Danielle, Dats misses you, just so you know. Okay. See you later. Have a good weekend.
Bye.
Bye.
Leave.
Okay.
Leave.